In this module, we'll be discussing life cycle assessments. A life cycle assessment, or LCA, is a standardized methodology for quantifying the environmental impacts of a process, product, or system over its entire lifespan. This tool is used as a means of identifying where carbon reduction opportunities lie in the use of a building material. While specific in application, this tool is comprehensive in scope. For the roadway industry, 3 main levels of life cycle assessment can be identified. Product or material level LCAs take one product specifically into consideration. This could include hot mix asphalt, ready mix concrete, or aggregate borrows. LCAs at this level are typically communicated through environmental product declarations, which come with their own verification process that will be covered in a subsequent video. More comprehensive LCAs are divided into either roadway element or whole roadway assessments. While the roadway element structure accounts for a collection of materials used to build an element of a road, such as pavement structures or traffic control systems, whole roadway LCAs cover the entire construction project. When considering the relative degrees of impact from different materials and processes, it is no surprise that pavement LCAs are the most common. This subset of roadway element assessments outranks whole roadway LCAs in use, primarily because restricting the scope to 3 materials, asphalt, concrete, and aggregate, makes the documentation process far simpler. Pavements are also among the largest contributors to the total embodied carbon of roadway projects, so this simplification is an effective measure. In conducting either a whole roadway or pavement LCA, there are 4 mandatory steps. Step 1 sets the goal and scope of the life cycle assessment. While the LCA goal describes the primary purpose of conducting the study, the scope determines functional units, analysis period, system boundaries, study limitations, and more. Scope can be broken out further into physical versus life cycle scope. While physical scope determines which roadway elements are to be included, life cycle scope identifies the relevant LCA phases. Step 2 begins the life cycle inventory, or LCI analysis. This involves compiling a list of all inputs and outputs for a roadway project as quantifiable data. This data primarily includes material quantities and compositions and should be broken down into the smallest component possible. The results of this inventory then establish a link between the physical properties of a material and its environmental output. Step 3 calls for a life cycle impact assessment, which uses the LCI results to then calculate the environmental impacts of the products in question. These are then reported using impact categories and impact category indicators. An example of this would be global warming potential being reported in carbon dioxide equivalents. Step 4 is interpretation. This final phase of an LCA calls for an interpretive analysis of the study's numerical results, including metrics such as data summaries or hotspot and uncertainty analyses. After drawing conclusions and an optional peer review process, the life cycle assessment has been completed.